Hello friends, welcome back to my classroom. In this class, I'll try to explain what stochastic process is. A stochastic process is a collection of random variables indexed by time or space. Okay. So far we have studied about the random variable x, which takes the value based on outcome of a random experiment. Now, instead of studying a single random variable, if we consider a set of random variables indexed by time, say x0, x1, x2 and so on. So this sequence, the entire sequence forms a stochastic process. So this is a very simple definition. Hope you have understood. It is not just a single random variable. It is a sequence of random variables. This forms the stochastic process. Let's consider a few examples. Weather changes. So weather change, the temperature changes every day. Okay, maybe on first day the random variable x1 represents the changes in the temperature. On second day we represent it by x2. On third day the random variable we represent it by x3 and so on. Okay, so this is a family of random variable. So this is a stochastic process. Similarly, you can consider the stock price movement. So stock price movement changes every minute, right? And similarly, rainfall over months. Okay, you may consider x1 for first month, x2 for the second month, right? Similarly, the number of customers arriving per hour, every hour. So the number of customers will be different, right? Uh, Let us see some more definitions that will be helpful for Markov chain and to understand what is transition matrix and the higher transition probabilities. Okay, first let us understand what is probability vector. Okay, probability vector is a vector whose entries are actually probabilities. That means the entries will always be uh, in between 0 and 1, right? So it will and also the sum of all the entries is equal to 1. Such a vector is called as a probability vector. Let me consider few examples. So P 0.3, 0.2 and 0.1. Is this a probability vector? Okay, this is between 0 and 1. 0.3 is between 0 and 1. Okay, and 0.2 is also between 0 and 1, and 0.1 is also between 0 and 1. This is satisfying first condition, but what about the second condition? Is 0.3 plus 0.2 plus 0.1 equal to 1? Okay, no. 0.3 plus 0.2 is 0.5, 0.5 plus 1.1 is 0.6. So this is not a, P is not a probability vector, right? So let me take one more example which I have given here, right? Here 0.6, 0.3 plus 0.1, 0.6 plus 0.3 plus 0.1. This sum is 0.6 plus 0.3 is 0.9 plus 0.1. So totally this is equal to 1. So this is a probability vector, right? That means entries should be always between 0 and 1 and total should be equal to 1. Then such a vector is called as a probability vector. So one more example, if you consider P equal to 1 by 3, 1 by 3 and 1 by 3. This is a probability vector, and let me take one more example, 1 by 2 and 1 by 2. This is a probability vector, right? So P is equal to 0.1, 0.2, 0.6 and 0.1. So this is again a probability vector because the sum is equal to 1, right? So now once you have understood the definition of probability vector, it is very easy to understand what is a stochastic matrix. Okay. So stochastic matrix is a square matrix used in Markov chains. Alright. The condition for a stochastic matrix is very simple. Every row should be a probability vector. Now you have understood what is a probability vector. The sum should be 1. So here every row should be a probability vector. That means every row the sum should be equal to 1 and all the entries should be between 0 and 1. Okay. Let me take a square matrix 0, 1 and 1 by 2, 1 by 2. So first row is all the entries are between 0 and 1 and also 0 plus 1 is 1. Right. Second row also all the entries are between 0 and 1. This is 1 by 2 plus 1 by 2. The sum is 1. So since the sum in every row is 1, this is a stochastic matrix. Alright. So let me take a 3 cross 3 matrix. A is equal to 0, 1 by 2, 1 by 2, 1 by 3, 1 by 3, 1 by 3, 0, 0, 1. Yeah. Is this a stochastic matrix? Okay. So very easily we see that this is a stochastic matrix because half plus 0 plus half is 1. 1 by 3 plus 1 by 3 plus 1 by 3 is 1. And 0 plus 0 plus 1 is also 1. Right. So very simple definition. If every row of a matrix is a probability vector, then it is called a stochastic matrix. Alright. And moving on, let's understand what regular stochastic matrix is. Okay, all the stochastic matrix need not be regular. So to be regular stochastic matrix, some power of the matrix should have all the entries positive. Okay, definitely there will not be any negative numbers in stochastic matrix. Only thing is 0 should also not be there. Alright, every entry should be positive entry. Not for the given matrix P, for any power of P, if the entries are positive, then it is called as a regular stochastic matrix. Okay, suppose P is a matrix. So I want to check whether it is regular or not. So either P square, what is P square? Matrix P into P. So to understand how to multiply two matrices, you can check the video. The link is given in the description box. Alright. So P square is equal to P into P, or P cube, which is equal to P square into P. Alright. So in any power, so for some power of P, okay, for some n, P power n should have all the entries positive. Then it is called as a regular stochastic matrix. Alright. Let me take a couple of examples. So I'll take 2 cross 2 just for understanding. For any order matrix, you can check by multiplying two matrices. Right. So I'll take matrix P is equal to 0, 1, 1 by 2, 1 by 2. So the question is this a regular stochastic matrix? First of all, it is a stochastic matrix because sum is 1, 0 plus 1 is 1, and half plus half is also 1. Okay, that's clear. This is a stochastic matrix. The question is it regular stochastic matrix or not? So in P, I am seeing a 0. All the entries are not positive. So let me try for P square. So P square. How to get P square? P square is actually equal to P multiplied by P. So this is 0, 1, 1 by 2, 1 by 2 multiplied by 0, 1, 1 by 2, 1 by 2. So we'll do the matrix multiplication. Once again I am telling, suppose you don't know how to multiply two matrices, you can check my video on matrix multiplication. Okay, the link is there in the description box. Alright. So this is 2 cross 2 matrix. both are 2 cross 2, so the result will also be a 2 cross 2 matrix. So what I do, I'll consider first row with first column, the sum product, first element in the 0 into 0 plus second element 1 into 1 by 2, 1 into 1 by 2. First row, first column is done. Now instead of first column, I'll go to second column. First row, second column. So first row 0 into 1 plus 1 into 1 by 2. Right. So this is done. First row, second column also is done. Now instead of first row, I'll go to second row. So second row is this. Alright, where half and half is there. Second row with first column. Second row with first column. Half into the first element is half. Here the first element is 0. So half into 0 plus second element half into half. 1 by 2 into 1 by 2. So second row, first column is done. Now I'll go for second row, second column. Second row 1 by 2, but second column has the element 1 and half into again half. Alright. So if you compute this, what will you get? 0 into 0 is 0 plus 1 into 1 by 2 is 1 by 2. Here 0 into 1 is 0 plus 1 into half is half. So this is half into 0 plus half into half is 1 by 4. Half into 1 plus half into half is 3 divided by 4. So this is p square. So we can observe in p square all the entries are positive. So we can conclude that the given matrix P is a regular stochastic matrix. This is a regular stochastic matrix. Alright. So let me take one more example where this is, I'll write it here. I'll just write the matrix which is not a regular stochastic matrix. P is equal to 1, 0, 1 by 2, 1 by 2. Alright. So you can check for p square. P square will also have 0 in the second row, second column. Then if you try for p cube, that there also you will have 0 in the same position. Alright. You take any power of p, this will never become positive. So this is not a regular stochastic matrix. Right. So hope you understood how to check whether a given matrix is a regular stochastic matrix or not. Right. Fine. So in the next class, I'll try to explain what is Markov chain and how to get a transition matrix. Alright. So thank you.